Hello, hello. All right, so yeah, currently working basically to get things up to shape here. Yeah, trying to get this script here to pass. So let's see. Expected answers. Yeah. So let's go to the parser because we have a thing here. Right. In all binary expressions, identifiers are treated as calls, but now we need to actually have the context of the operator, because in the case of a member access, which are now made into a binary operator, because it was easier to implement it in the parser. In the case of an operator, we don't want this to be a call. We want an identifier to be just the identifier. So this is the identifier, and this is gonna be an expression. So I mean, I guess we could have an if in here. We could also have like an special function or something, but I'm just gonna add an if in here. If operator is equal to member, then we will do this. Weird. If that is true, we do that. Otherwise, we do something else, or the other way around, rather. If it's a member, we treat it as an identifier. Is there like a from token? I forget. From token identifier. Oh wait, this is an actual identifier. Okay, we can just pass that in. There we go. Yeah, I don't really like this setup here, but okay. Let's do this. We'll put you in there, and self to identify expression. There we go. Alright, and then it's like if, well, okay, we probably want to have the identifier as well. Let's do that, okay. Identifier. If operator equals member access, we will do return that. Otherwise, return no. Okay. Well, okay. In this case, we don't really have an operator, I guess. So I guess it's optional. There we go. Okay, and then we have a similar thing down here. Parse binary. Yeah, okay, sure. I guess that's fine. I'm gonna try some other expressions. I'm just trying to figure out when this is a problem here. When would you start game dev? I don't know. I am going to. Don't worry. I'm just in or not compiler, but programming language land right now, and trying to find my way out. Are you doing any game dev? Let's see. Okay, so this could happen, I guess, when the left hand side, the right hand side is if you have an expression like this. So like a dot b dot c, right? This is gonna be like this. Okay. So let's just take this basic example here. Now this is fine. It checks if this is an identifier. Now this should also be fine. The left hand side is that. This is dot. The right hand side is now. Well, we're not even going in here, so that's the thing. But let's say we had like add 3 here. Now this would be a bit different. Well, it wouldn't actually be different. I think at first it would actually group like this, and then this would be parsed as a thing. So that's gonna be the same thing. Yeah, I don't think there's an issue here. It's just that this operator probably will never be. It won't ever be a non-member access, because member access has like the highest precedence right now. Yo, Penguin, what's up? Okay, let's see what we've got here. Okay, we don't get any errors anymore. And let's look at this inspect here. And here we've got a member access operation with left hand side is S, right hand side is done out. So that's nice. Okay, so now, okay, since yesterday I also added this inspect function, which is like a built-in function right now. if we go to run script, I have this add built-in functions thing that will take the scope and declare a bunch of functions on it. So they are hard-coded functions that have special expressions that will do special things that we can do whatever we want in the thing. So here we can take any kind of expression here and inspect it. And it's going to get evaluated right now. So if you do like an echo in here, that is going to get, actually, since it's a function call, it might, we should probably bind it. I don't actually remember how we do that. The params, yeah, that's probably not happening right now. The params are probably just evaluated directly. But anyway, you can take anything here and inspect it. And what is the outcome now? Well, first of all, get stuck. Well, that was the issue we had before. But it's a string that's empty. Okay, so it's an empty string. What if we had something that doesn't exist? It's an error. Okay, cool. And then we have standard error. We're inspecting a string and it's empty. Okay, and then we have exit code, I think. And that's an exit code and it's null. Right. Well, the exit code is always null by this at this point. And then if we inspect S itself, then that's an execution. Okay, so there you can inspect a whole bunch of different things. This though, well, okay, first of all, why is std out empty and why do we get stuck? So that's two issues now. So right, so let's go to evaluator, execute binding. So what is happening here? Well, these things are reader writer streams that is used in the context that we're pushing in a context. So basically what we're doing is we're running the function or running the expression. When you bind something like this, the part that's on the right side of the assignment operator is ran in a special context where we capture everything that's going on in here and basically putting it in S. That's the idea. And that's what we're doing here. We're pushing some contexts into the context stack where we have processes. We will capture all processes that's been spawned. We capture all the output from that goes to standard out, standard error, and we also block standard in. Yeah, because we don't have a standard in when we bind something. So yeah, and then the expression gets evaluated, which could spawn a bunch of processes, could do whatever, you know. And those processes get captured here. The standard out and everything gets captured there. And then we also do this processing binding value, which will take these streams and it will process it. Okay, I see. I think I know what's going on actually. So what I think we need to do actually is execute this expression, not evaluate the expression. We need to execute it because the execute will it's kind of like a blocking thing, where the execute is like taking all the right. So execute Actually, execute already has a processes thing. But okay, so execute will evaluate in the process context. And then we also wait, we kind of process the output as well. So we're taking, yeah, we're forwarding everything that has been pushed while standard out is not closed from the whatever it is. How will this work actually? We get the pipe that's in the current context, and we stream the standard out to the outer context. I'm just trying to figure out like what is what. So like this is not the standard out of the main thread, you know. This is the standard out of the current context in the scopes. So it's gonna be whatever is in the context when you call this. And so when this is called from outside, it will call this. I was just trying to, because I think that maybe this is why the issue exists. But let's just see if we can use execute expression instead. And then at the end, we will end up with some value. Well, the value is whatever we got from the expression. Yeah, that should be fine. Okay, so now let's go to, where were we actually? Evaluate, no, execute binding. So execute binding. So the problem here is that why we don't get anything is because in standard out of this value is because we just evaluated that will spawn the process, but the process hadn't have time to output the echo yet. So when we process the value here, it's just gonna go in, take whatever's available here right away, but there's nothing available yet, so that's why it's empty, I believe. So what we need to do is execute this expression, and that will hopefully, you know, flush out everything. No, not binding, expression. That will hopefully flush out anything that was held up in that expression, and we have access to it afterwards here. Hopefully. Okay, there you go. Now we can see that we actually got it. But we still get stuck here for some reason. Now this is probably at this point, because this was already executed. Although you could probably argue that we already got stuck here, but or stuck after this maybe. We'll see. But great, that actually solved that. Let's add executor so we can see a little bit more of what's going on. Hang on. Why is it exiting now? Is there some error with... Oh. Document not found. Right, okay. Yeah, it's big. Okay, it's when we evaluate expression, we log the expression, which logs the span. But the span, if the span is global, we don't know. We can't really show it. So what we do is we will say, yeah, the file here is like it doesn't exist. So we have to do if span is equal to global. Well, I'm pretty sure there's like an ASD span global. Okay, we can't check for equality against global, but we can check. So that's like location. Where's the token? File. Let's add a function here, is global. Now we can actually do, I think because file is a is set to this thing, we can actually do like pointer equality check here, probably. So if file pointer is equal to global file pointer, that should be true, right? Hopefully. Maybe that's a bad thing to check for pointer, but it just feels like it should be the same. Maybe we could also check like if all of these are 0, then it's global. Yeah, let's do that instead. And then we have the span somewhere. Return self start. We just need to check one. All right. Now we can check if it's global. Then we will. We can't really show the source code. This is all like printing out the source code and stuff. So what we do is we just say I'm just gonna show the file name, I think. And return, of course. Got some error somewhere. Expected tuple. Oh. I don't know why. Usually, I always do that. Okay, there we go. Except we need a new line. Okay. So, where are we actually? We are evaluating the inspect here. Found a string, hello. Run function is complete, and now it's like stopped for some reason. So let's check if we are at execute expression. We're gonna do here, no, here. We're gonna do, well, actually, we could just enable the stream logs. and we'll see what's going on. Okay, we got an infinite loop here, standard out. Okay, I should have just went to the top there. Wait, does it really fill up that fast? Yeah, god damn it. Okay, but anyway, we can see that we are in fact stuck here. Okay, here we go. Yeah, so directly after we have done the expect, it's gonna start, and so I'm gonna say that, yeah, this is in the execute binding thing, and or execute expression thing, yeah. And so let's see. Yeah, this logs forward, and but then I guess maybe it's because we don't have a source, or I'm not sure. If we don't have a source, let's log that. No source connected. Well, let's just log that. Okay, no source is connected. So, okay, let's see. So, actually, which execute are we in? Are we in the inner execute or the outer? I think we're in the outer execute, because otherwise we wouldn't have seen what's returned from the inspect call. So we're in the outer execute expression, right? So this will refer to probably the, well, it's gonna refer, yeah, it's gonna refer to the actual standard out pipe, which now has been disconnected of the source. So I guess if it's disconnected, we, at this point, we can just we actually can just skip this part, because if it doesn't have a source, where there's nothing to forward through. So actually, maybe we should return more than a bool. Maybe we should return like no source. Yeah, that makes sense. Forward event. You were impressed, but then you realize it's not C. Well, it's better than C. It's zig. Okay, so the source is gonna be either, well, no source, closed, or not done. Or something, I don't know. No source. Closed. 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 Well, actually, this is more like error, but whatever. What is the language? The language is called Zig. Z-I-G. Just like the name here, the extension. You could kind of think of it as like a modern C. Although I have basically no experience with C, but so take my word for it. No, but it's like, it's low level, it's manual memory managed. You can write assembly if you want, but that's not what we do normally. Well, I don't anyway. But yeah, it's really cool. Right, so now we have a bool instead, and so I mean, we could just, couldn't we just do this while this is not equal to not done. Now we kind of also doing this. Right. So either the stream can't, like, it doesn't exist, but then also do this as well. Standard out stream. If we have the standard out stream, we grab it and run a while loop on it, and now we don't have to do the unwrap there. There we go. Now we can remove that. Okay, so in this case, the connection could have been, well, if we didn't have a connection at the at all, we will get, this will be, well, the result of this would be not connected. So, or yeah, so this would break out. Yeah. All right, now we got the same issue here. Now this one also, actually, we need to look for closed here. So that only looks for closed. There we go. Same thing here, closed. And I guess standard error is, well, we'll just ignore standard error for now. All right, that was that. Still get this infinite loop. Okay, so we're still in the same spot. I am a little bit confused. We can't be stuck here because we already Evaluate expression. Found string, yes. And here's the actual output. So we just log out the output, and then the function is done. And then it goes out to, presumably, out of this to the next one. However, before we do the next one, it's gonna try and stream out everything that's been streamed here, but it gets stuck. So I think we are in the correct place. Oh, wait. No, but okay, so actually we don't even get here because execute binding is a separate part of that. Oh, wait, no. Okay. So what's happening? No, no, wait, we are past the binding. We're way past the binding. I mean, why am I? Yeah, this is the binding. We are already down here. It's the end of this one that's getting messed up. Yeah, okay. Okay, yeah. So, but still, it should, while it's not equal to not done. Wait, while it's equal to not done. What the hell? Okay, there we go. There we go. All right, so now we got this working. Finally. Okay. Yeah, it's a little bit slow. I've mentioned this a couple of times, but basically it's because I'm running Windows with Linux under a virtual machine WSL. And so even if I just type echo hello, it's gonna be, you know, it doesn't happen straight away. So that's why it looks like it's super slow. Although I'm not saying it's a super fast language. The focus of the language is not to be fast. It's to be, you know, productive. But yeah, okay, cool. So so let's try, you know, cat. Hello, cat. I think if you do this, it will log out, concatenate thing. So yeah, so this all works. Awesome. And yeah, and yeah, okay, cool. So what now? Man, I feel like we just closed an insane chapter here. Actually, I think I should just merge this now. Yeah. Okay, so reworked pipelines. I'm just okay, hang on a second. I will, yeah, sure, whatever. I'll just merge that in here. All right. So, okay. Cool. All right. Another thing I want to do is I want to see if this still works. Yeah, okay. So we got the same issue. So basically, yeah, it works, and it was super slow as well. But we'll try to optimize a little bit later. But at least it works. However, we get this segmentation fault, of course, and it's some closable thing. All right. Does Zig support OOP? It's a complicated answer to that simple question, actually. But what it kind of has is like, well, it doesn't have straight up OOP. It doesn't have built-in, you know, like classes or interfaces or stuff like that, or inheritance or anything like that. But you can kind of like, you know, build your own things with something that's called comp time, and like, or yeah, it's a combination of like compile time features and runtime features. So basically you can build your own vtable and have Zig wired up for you, basically. But yeah, you kind of have to do a little manual work to get that kind of thing working. Yeah, I don't know about C, but I would imagine they could do something similar. It's just that Zig has a little bit more... well, okay, I'm not going to say anything. I was just going to say that Zig has more safety, but I can't honestly say. But, yeah. So it's basically... I can show you here. Like, I have a thing called closable, which is kind of like an interface. So this... Well, this is also a generic, so it makes it a little bit more complicated. But basically we have a generic type variable here. And it's basically so the idea with this closable is something that you can close, and you can attach a value that it was closed with. So kind of like a return value. And so we have these functions here: close, get result, is closed, right? And you have your vtable here, which is, you know, it's a struct that has a bunch of function pointers. And so whatever this vtable points to, it's the implementation you're gonna call. And we're also using a little bit of magic with a thing called field parent pointer, which kind of makes it so that you don't need to store the data in here or any kind of pointer to the data. The data can be stored on a struct that has this closable on a field, and then it can kind of backwards calculate the parent struct where this field is located, and that's how you can get to the data. So it's a little bit complicated there, but yeah, it is possible to have this, pass this type around and talk about this with different implementations underneath. You may be getting segmentation fault because you are accessing an argument vector that doesn't exist. Yeah, maybe. We will see. It has something to do with the closables here. So we're trying to call this get result on self, and we get a seg fault. Now we get an address here, which is nice, because then I can... Wait, no, I can't, because this is not a ref. The source. It just happens in a for loop, actually. So the for loop, it might be that we just didn't update, because I've recently reworked how the pipelines work. And let's see, for expression. I think maybe here we should actually call like execute. no, not this one, but when we run this for loop, it should be ran as like each statement is ran with its own thing. I think that's what we're trying to do here, perhaps. We run the okay, yeah, so this should actually do that. This should execute the thing, yeah. Whoops. It could actually be that it's connected. Okay, it could be. I think, okay, I'm gonna predict something. It should happen the same way if you do this. If you have a function and we have echo hello. Okay, let's just see if this works first of all. Yeah. And then we call hello. Okay, that works. Good. What if we do twice? Why is... Oops. Like, why is the for loop special? I mean, there's a different evaluation thing for it. Let's try an if here. If true. Okay. And then you can also just have a block as well. But, okay. Actually, do we allow for loops? Okay, let's do this. Let's change the for loop to be just an expression, because that's what we want anyway. Now that blocks can be expressions, so we can just put that there. So yeah, this is not a block. This is just an expression. And right, so this is now an expression, but okay, so if it's a for loop, do we execute it? Because otherwise it won't get streamed. I think we execute. Yeah, execute. Hello, two-step. How's Runic going? Syntax is nice and simple. It's going pretty good. I mean, it's going pretty slow. but it's yeah, it feels like I had a bunch of forward momentum, but then it was like, yeah, okay, now let's implement streaming in pipelines, and that took a while, and now we're kind of back because it changed like a lot of how stuff worked, and but yeah, I think we've landed on a platform now that we can use to build the rest of the things up on, so that's really good. I think the only major thing left is like functions and making them work with, you know, having pipelines and streaming and all that. We'll see how this works though, but yeah. So run block. What is this? Run for expression. Oh, this is a type checker. So we're just gonna run expression. There we go. Except this needs to be like in its own thing, right? Or yeah, it needs to be in a new scope. Actually, it does need to be in its own scope. It needs to be run in the for scope. It is already run in the for scope. Okay. There we go. Okay. Oh, interesting. It like fails on the last. No, I don't think it did that before. But okay. Anyway, if we do this, that should also work. Yes. Well, it should also fail, I guess I should say. Okay, so we got this. Now, my inkling is that, because kind of like how the pipes work is that they have, because it's like here we have like an invisible pipe that goes to standard out, right? And this invisible pipe is shared between all, like every statement now, basically. And sometimes it has, so each pipe can have a source connected to it and a destination, right? So this destination is, you know, standard out, and the source is whatever standard out comes from here. So so when you connect the source to it, actually we should probably have to create a new pipe for each one. Because if we use the same one, yeah, I think that's the issue. We're reusing the same pipe. We have to create a new for each one, because you could potentially have multiple connected, and that doesn't work. But right now it's like everything is synchronous, so, but yeah. All right. Go ahead, Discord in SM. Yeah, as I said before, so there's like the foundation of the project is built with AI, but then AI couldn't complete the project. It like got stuck, and then I took over and I realized, hey, this is like a bunch of AI slop, and then I took over and now I'm basically trying to build it almost, not really from the ground up, but all the like expression evaluation and the type checking and a lot of the parsing I've built from the ground up, since AI couldn't do it. So but yeah, hey, that's more fun anyways, right? So it was just an experience to see like how good AI is and how far you can get to actually use AI to build it. But then I mean I like building this myself, so it's not really a problem for me. But it was also a nice experience to see. Okay. So yeah, it's available on GitHub there. You can see the thing in the description. And yeah, I just merged the pipeline changes, so there you go. If you want to look at that. Yeah, I mean, I would not recommend. I mean, sure, you could use ChatGPT, but for some reason it works really well with like I think it's 0.13 or something. It's using 0.13 probably in ChatGPT or in in what the codex I'm used, but I guess that's based on ChatGPT. I don't know. And it was using like the older version, so it doesn't have like the newest things, but like there are minor differences. There are differences in the build system, but they are pretty minor, I would say. But if you're trying to like build something with Zig with using like ChatGPT or something, it's gonna use like an older version, so you have to keep that in mind as well. But okay. Okay, should we create a new pipe for each output? We might. I mean, what we could do actually, we could for each execute binding. No, not binding, expression. We could also push a new pipe on here. This, I mean, it's inherited, but we need to create the thing. Wait, aren't we popping? Yeah, we are. Okay, there we go. Right, so we need to create a new pipe here. So what's happening? What's happening? Why can't I see what's going on here? Is there some syntax error somewhere? I don't see it. Oh, it's okay. There we go. Alright, so we got this standard pipe. And we need to connect this destination to the actual standard out. You know what? Let's create a scope here actually. Just for naming purposes, like here's standard out, and we're gonna connect you to standard out. I mean, I guess it's the destination here. Like this is a pipe that goes to standard out, and now we're creating a new pipe that should have the same destination. And I guess if we don't have a destination or a pipe, we can't do it, but this should. Actually, now we can just do this. If get standard out pipe stream, we get that there. I just want to ask a question. Do you know all the things per se language perspective, like each and every syntax, but when I start building something I might not know everything. I have to look up docs. I help AI. How can I be? No, sorry, I don't know everything. That for one. I mean, if you see me remember something, it's just because I've done it like a bunch of times already. And well, I've been programming for a long time as well, so a lot of the patterns in programming are like repeated throughout different languages. So like a lot of things are also like, you know, ingrained from a long time. But yeah, it's just a matter of you know, practice, I guess. And I mean, there's no shame or anything in like looking up stuff. Like I do that all the time, like looking up, you know, how you know, whatever, if there's syntax issues, if there's like how different like built-in stuff works, standard library, there's all kinds of stuff that you have to look up. You don't actually, it's bad to have everything in your head, because then you don't have room for being like for anything else. So basically, I don't think it's good to try to memorize everything. You should instead learn the skill of looking stuff up. That is like a super important skill to have. And of course, you have to have some kind of context to kind of reason about things, and of course, sometimes it does help if you remember how to write an if statement or whatever. But you know, it's not necessary, and it's more necessary to be able to look stuff up. That's a more important skill, because without that, you won't get anywhere. Because you can't memorize everything. So that's my 2 cents on that. All right, so your destination, but you can be you can not exist as well. So we have to have another if where we say standard out stream destination, and that is the destination we need. And let's just say that if we created standard out type, we did it, and then there we go. And then if we created a standard pipe, we will pop the frame. There we go. It should be like this. It doesn't matter because we don't care what we pop, we just care if the number of pops we make. And I guess we do a try here. Oh. Yeah. So, well, but then this pipe, we need to... Oh man, we need to keep that pipe around actually. So let's make a break here. I don't think, can you make a break here? I'm not sure if you can. It's gonna have to be here, like at the block. Yeah. If we didn't get anything, I'm gonna break null. But otherwise here, we're gonna break that. So now you are either a reader writer or null. Okay. So there's our pipe. So now we don't get the pipe like this. We will do standard out pipe forward under it, not done. There we go. And then if we have it, we do that. I guess this, okay, I guess this is also like if we have it. We do that. I guess we can move this in here. Oops. Becomes part of the process, so you need a second one to keep docs open, even a simple language. Yeah, I mean, you can alt tab as well, but yeah, you know, especially in like I'm using also like the LSP to help me. You know, I don't remember every thing. LSP does help me like navigate. Like if I want to go to this, okay, now it doesn't work. But I think it's because it's a syntax error somewhere. There we go. No? Oh, I see. There we go. Yeah, but it helps like catching errors, moving between, jumping between files and definitions and everything. Getting like information, you know. And you know, the documentation, you have to look up stuff all the time. Here's a really nice answer. I'm stuck with now between C++ and in middle. I'm thinking of there's no use coding, like I lost motivation to code. What do you do in this case? Yeah, I mean, I get that. Like, do you mean like because what kind of project are you making, or are you just learning, or where are you like with that? Because I feel like I can get that a lot of times when I do a project and I work on it for a while, and then either I get bored of it and I jump onto something else, which feels bad because I really wanted to complete the project. But it's like, but the thing is, like, you also, like, a lot of times I get stuck and I just can't progress. And I try and I can't go past a certain obstacle. And I do think that with given like experience, the more experience you have, the more obstacles you can progress through. And you can kind of know that, okay, well, if I try to find this issue here, we can get past this, you know. But yeah, it does take a lot of energy. And sometimes you just feel like, man, F this. I'm just gonna give up here. And then it's kind of, you lose kind of momentum, and oftentimes that's the point where I move on to something else. But it still feels bad. It still feels like I would like to create something here, but I can't. And so, well, I can. I could have maybe, you know, if I kept going, but I didn't have like the energy to do it. So yeah, it kind of warps your idea of the project. It feels like into something that is more of a burden or something like that. More, it takes the fun out of it, I guess you could say. Now that's also something you have to keep in mind as well. Not everything is going to be fun all the time. Of course, you're gonna have to jump over some hurdles and fight with the computer a bunch of times but that also, it's kind of good as well, because when you eventually get something to work, then you reap the rewards of it. So it's an amazing feeling when you've worked on something for a while and then it just works, and it's like, yeah, you feel like you can make, you know, you get the feeling that you can make anything. How's your experience on using AI in this project? Yeah, I will say AI is like, I'm very impressed by what AI can do. I was actually more impressed than I thought I would be. I was surprised how good the AI has become. But I will say, oftentimes when you deal with AI, it's like very often, if not always the case, that it's like you get this sense of awe what the AI can seemingly do. But then when you dig into the details and you're kind of looking at what it's actually doing, and you know, trying to you see that, okay, well, there's some cracks here, there's some issues here and here. And the thing is, like, if you're trying to build a project using AI, like only AI, that's just not, I don't think that's gonna work, unless you have to put in a lot of work yourself in order to see what's going on and to be able to direct the AI to do the correct thing. Otherwise, it's just not gonna work. You can't just tell AI, hey, do this project, and it's gonna do it for you. That doesn't work. You have to put in a lot of work yourself. So yeah. And, you know, to be honest, like, if you are not a developer, I don't see how you could create a larger project right now with AI. I mean, you might be super good at prompting, I don't know. But it's just like, if you encounter some kind of issue in the code, or that's a bug and AI can't solve it, and you're like, well, just solve it. It just can't solve it. You have to go in and do it yourself. You're currently doing data structures in C++. Okay. What what is the reason for learning? Like, are you in school, or is it like by yourself, or do you want to build a project, or what? Do you know any good spec tools you can use to plan and design a project? I don't know. I'm using Markdown. What the hell are these milk toast basic questions around basic models? Just go out and code. It's not that difficult. I mean, you can get like, you know, I've been experiencing a lot with like, you know, building a project and you get stuck and you like give up on the project, you know. I've been experiencing that a lot, and it's like, it doesn't feel good. So I do understand, you know, I have the same feeling sometimes. It's like, but yeah, it's also like if you don't feel like it's fun at all and at any point, I'm not sure if coding is for you. I'm just gonna say it like, you have to kind of, I mean, okay, there is the kind of, when you're starting out, you have to kind of put some work in before you get some rewards out. Or you have to have at least some interest in computers and, you know, the whole programming thing to feel like, yeah, I'm interested. Because it's going to be super hard otherwise. You're learning for college. Well, are you interested in programming? Alright, so this one is, yeah, standard out is destination. That's the writer. And then standard, I'm just gonna say inherit here, whatever. We don't care. Okay, so now we have a new pipe. Whenever we create a new pipe, whenever we execute an expression, we create a new pipe. We connect it to the same as the current standard out in the context. We execute the expression. If we got a pipe, we let's attach a pipe on there. Okay. If we have a pipe, we will forward it and until it's done, and then we do that. I think we might actually run into the same issue here, but we'll see. Maybe not. Oh yeah, init destination, whatever. Hang on. No, this is standard out pipe. Yeah, there we go. Expected, found, void. No, else, no. Okay. No more errors. Okay. I saw that the loop went through, but we get maybe a bunch of leaks here. Oh yeah, so let's do like defer if standard out pipe no. Right. Hey, there we go. And it's just as easy as that. No. Okay. No more leaks in the for loops. Awesome. Now, does blocks still work? Yeah. Cool. You're interested? I think it's best to take a short break and come back later. Thanks. Yeah, no problem. Sometimes all you need is a break. I think as long as you keep doing it, you're gonna, you're gonna understand. Like sometimes you also need like a different perspective. You know, I remember when I first started out, barely now, but yeah, it wasn't easy. You know, getting your head around certain things. It was all like some things felt more easy than others, and you have to get over a couple of hurdles before. And also, like at the start, it was also difficult to understand how to break things down into smaller problems and build it up again. That was a major hurdle for me when I first started out. But you know, you just get better and better, and at one point you will be almost self-sufficient. All right, but then it's also like you will never stop learning. There's always more things to learn when it comes to programming, and that's what I like about it as well. It never ends. And even if you do get to the end of what everyone has ever thought of, you can still make up new things. So it's like, I don't know. It's pretty cool, actually. Okay. So, yeah. This all works. Now, I wonder... Okay, now that stopped working. Okay, great. No. Okay, this binding doesn't work anymore. Ooh, is it because... No. Wait, why would that not work? I mean, it's probably because of this, but why would that be an issue? Because the idea is we push this frame forward. Now the standard pipe, whatever is connecting to it, is going to connect to this pipe instead of this one. How many years have you been coding? I've been coding professionally for 10 years, and then before that, I started learning. I was self-taught in C++. 20 years before that. Because I wanted to make games, but it was very difficult for me. But then I realized that, hey, I really like programming. I really like building stuff that I can see the computer's making me, or I'm making the computer do what I want it to do. And yeah, that was some kind of controlling behavior. I don't know. Shoot. I'll just BRB 1 second here. I'll be right back. All right. Yes. I mean, yeah, we are basically control freaks. Programmers are control freaks. See, this will set up the pipes with no destination, right? Okay, I see. That's why. Yeah, so these have no destination, so that's why that's not working. I mean, maybe we should. Maybe this has the responsibility of doing it then. Like, if this happens, we funnel the things out here. Okay. And then we actually, okay, and then we don't execute, we just evaluate. Okay. There we go. It's that easy. All right. I do not enjoy the fact that it's so slow, but I'm trying to not think about it. Hello, sir. How do I enhance problem solving? You practice. Start small. Practice on that and build yourself up. Like if you're building projects and you haven't built projects before, you should probably start with like a small kind of project, or just when you're starting out, like just very small programs to learn how to do it, and build yourself up from there. You just gotta have patience to not think like it's very easy when you start out to, when you don't really know how, you know, where to set your the kind of the ambition level. That's also something that you will learn in time and get better at. That's also something that, you know, I struggle with now. And even, you know, professionals out in the field, you know, trying to estimate how long something will take is the hardest part, or it's like it's very impossible. and the larger the project is, the harder it gets, because you never know. You always underestimate how difficult a problem is. But I would say, like, you know, I don't know, what kind of projects are you making, or where in what stage are you right now? Well, okay, it feels like we've kind of closed the chapter there as well, like a little bit. We've got this working. Maybe we should just make... We do have the MVP stuff. Like, this is kind of... I was trying to make this, like, MVP comparison here. Down on the left hand side is Runic, is my language, and on the right hand side is Bash, and I want to be able to, you know, do the things that you can do in Bash in here. So, but I'm not gonna copy the entire language because that's gonna be take a very long time. The goal is basically that it's like it's gonna be sufficient for me to build whatever scripts I'm trying to build in Bash, because I'm not a Bash guru or anything. I don't want to learn Bash, and that's why I'm making this language here. So I'm making a language instead that will replace Bash for me personally. So it's like a personal project, but you know, anyone can look at it and use it if they want. But yeah, so this file is kind of like building out these statements that should like work the same in both files. So, and then I have this MVP checker or whatever. What was it called? Or check MVP? No, what the hell? Yeah, check. Okay, it's a Runic file. So Runic check MVP skip type check. I need to make the type check working again. Okay, they are the same. Hang on, check. This is like the first kind of quote-unquote real Runic program right now. And we don't have a way to look at environment variables yet. So I have this constant that I'm switching off variables with. So there we go. Now it looks like they are the same. Okay. So basically what this is doing is we're running the things which could have other like side effects. Like we are just looking at the string output here. We're just looking at the standard output. So we're running these things here, and then we're just checking if the strings are equal. If they are the same. If they're not, they are not the same. And we do a little bit of diff check here. So first we put them into some files by using bash here, because I don't have a way to kind of redirect things into a file yet. There's no way to do that right now. There's only way to do it to standard out. So basically what we do is we can just use bash to do it here. So this will store things in bash, or I mean in the bash result file, the Runic result file, and then we run diff on them to kind of show what the diff is, and then we remove those temporary files there. So that's how that works now. You can see I'm not a bash guru or anything, because you probably would have used some kind of super fancy temp file thing. But anyway, I know there's a way to kind of create a temporary directory, I believe, or something like that. I'm not sure. Anyway, so that's what this script is doing. All right. So what else can we do? We can do like a for loop, and this is like, well, let's do an if first, because I know how to do an if in bash. Let's do like if, and I guess true, echo true, else, oh my god, echo false. And of course we can't just copy and paste this, because that would be ridiculous. Then I wouldn't need to write this language here. Here you have to say like, I don't know, I actually don't know. How do you say just true? Maybe 1? I have no idea. Something like this. And then I think there's like a semicolon here, and then else, and then fi, which I heard someone say finished, But I've always seen this as like the reverse of if. Because there's like, it's like case as well. Case has like, it ends with ESAC. Yeah, anyway. Is this the same thing? I have no idea. Let's try this. They are the same, okay. Cool. Okay, just looking at this, which one would you rather use? No, we're not here to bash on bash. You can bash on my language how much you want, but okay, so that's an if. Now, if we can also do it like this: if true, echo true, else echo false. I think that will work. I actually don't know. It depends on if else is an expression terminator or not. How would you write this like in one line in here? It's like you do then. Is it then true like this? And then else false fine? Is that how you do it? Okay, it seems like it. Okay, so we got some not the same. So runic? Oh, I see. Runic failed, I think. Yeah, we don't see that. But there's just a 1 there. Okay, so let's enable, yeah, because the parser is also like recently kind of rebuilt as well, because the parser, before the parser, whenever it encountered a parsing error, it just aborted the whole thing. Hey, thank you. I'm not sure if I dare to pronounce your name. I'm gonna call you Hamish. Is that okay? Sorry. So yeah, so before the parser actually, whenever we encounter an error, it just exited the whole thing. But in order to kind of use the AST, even if you have a parsing error, we have to keep going and report errors along the way. So that's the new way of doing it, but it's not fully implemented yet. So sometimes we just get an error, and right now, as it happens, we just exit the whole thing without saying anything. So that's not great. But let's go to the parser, and whenever I encounter this, I usually I go to the parser and try to fix it up. So what we are doing here is we are we're going into the else here, and that's an unexpected token, so then we exit. So I think this should be, I'm gonna look if this is an expression terminator. It is. Okay, good. So no. So then the issue is that we don't have support now for like inline expressions like that. We have this binary thing, and this encounters a terminator. We break. That should be good. So why isn't it doing that? I think echo. I don't remember how we did with like function calls. Oh yeah, so basically, okay. We're okay. No, but okay. Function calls are also like a binary operation where the space between function and argument is the apply token. Or not token, there's no token there. There is no token, so, but it's the apply operator. But where did we add that? I forgot. Alright, here we do. Here we applied it. Okay. So that should get applied. And then the next we're looking for, actually, yeah, we're looking for, so I think if we get here and we get a terminator actually, then we should break. But the thing is, yeah, if we get a terminator, we break. But this basically only applies. No, that doesn't work. Because first we're getting an identifier. If we look at the no. So over here. First, if we look at this expression here, we get identifier, and then there's like, this is not an operator. So what we do is we check if it's a range, it's not. We check if it's an expression terminator, it's not. And then we check, actually next is like a string start. Yeah, but that's not a terminator. Anyway, and then we append a binary operation. However, we don't consume the thing. Well, it doesn't look like we are anyway. Yeah, so if it's like a normal binary operator, we append it. But if it's not, we're checking if first if it's an apply here. So this becomes an apply operator here, and then we get a string here, and then now we're in operator mode. So now we get terminator, so we break, right? So that should actually break now. I'm not sure. I don't understand why it's not breaking there. Or maybe it does, but maybe something else is wrong. So here we're starting the binary expression here. Oh wait. No, but this is an if expression. And then we parse an expression, right? Oh, it's parsing this entire thing. I see. Yeah, okay. That doesn't work. Okay, you know what? I'm just gonna give up on having no parentheses in if statements. I'm just gonna have it. It's just so much easier to parse. Where's the if? Parse if. Yeah, let's just force parentheses because it's, yeah. Whatever. I give up. Alright, now there we go. Okay. MVP. Check MVP, they are the same. Cool. All right. Awesome. What else? For loops. For loop. Okay, let's see how you do it here. I don't know. Now I have to look this up. Bash for loop range. Wait, how can I replace? I see. So you can do in. This is inclusive, I think. And then do. No, down. And then you can just do that. Okay. There we go. That works. So I didn't know this existed. That's pretty cool. Except in my language, let's do this. You can have like, I don't know, n equals 5. And you put n here instead. And then apparently this doesn't work here. And now you have to use something like this. What the hell is this? I have no idea what that was. Variable range end. Does it like autocomplete some secrets here or something? Like, what the hell? All right. Is this gonna be the same? For loop. Variable range end. Oh, they're not the same. Oh, I see. This starts at 1. Okay. Okay. What do I say? Do I have to say this and 4 here? There we go. Let's add some comments here as well. So here's like basic, echo, and pipeline. Also, I don't know, should I keep this? I can do like both this and this as comments. If blocks, if inline, for loop with, yeah, for loop, for loop, I guess dynamic range. Maybe we should create like a bunch of files instead. It would like execute each file. So because then you can have like a title or something. Like a bunch of different tests. We're probably gonna have something like that in the future. But yeah, this should work now. Yeah. Alright, what else do we want to have? What else do we have? I mean functions, but functions doesn't really work right now. Well, I mean they kind of work. But the types doesn't work. And I'm not sure if the parameters work. Maybe they do work now actually. I'm gonna try that. Let's do like greeting. And then echo. Hello. What is this? 1? Is it 1 or 0? That's 1. Okay, that also works. Cool. So apparently parameters did work. I forgot that I actually did that. They used to not work for a long time, but then I just made them, I guess. How far is the project from completion? I'm gonna say that you said there. I don't know actually. I'm trying to figure that out right now actually, because I'm kind of building up all these different things you can do, and then trying to mimic it in Bash as well here, so that we can see that there's no difference in the output. And yeah, and then there's gonna be like more. You can do other things in my language that you can't do in Bash as well, I guess. Well, or it's done in like a different way, but let's do like bindings. Let's do, I don't know. What should we do? Okay, well, we're just gonna do like string example is this is an example string. And then we're gonna do like echo results is echo of that. And then now what you can do is, because this type is like an execution type, execution result. And so what you can do is you can echo out. Now these two, nothing has been echoed to standard out right now. But here is like, we are going to say echo, and you can coerce echo result into its stand out. You can also say standard out here to get the standard out of the result. Now I'm not exactly sure exactly how all this is gonna work in the end. I just have some kind of way to extract the standard out from here, but it's basically stored in memory and then used up here. Well, it's not used up, it's just, you know, put into here. But yeah, so now let's see if we can do this basic thing here. And then of course there's gonna be type checks as well, which I've disabled for now, but or you can skip it with skip type check, because it doesn't support a bunch of different things. But I'm gonna get that up to shape as well, so we can get that working. And also it has like LSP, basic LSP support as well, except right now it's kind of broken because yeah, I've reworked a bunch of stuff, and yeah, I need to keep bring that up to shape as well. So maybe we'll work on that today, actually. Bring the type checker and LSP up to speed. And yeah. And then I think the next major thing that's left is like functions and typed pipes. That is gonna be a huge thing. After that, I think it's pretty much done. I mean, we got the redirections, writing to files, stuff like that, but yeah, we'll see how far we'll get. So this is basically, I think you can just do like, I don't think, can you have constants in Bash? Is that a thing? Okay, so apparently you can do like declare read only string whatever like this. Okay, so it is possible. I actually didn't think it would be possible. And then we have like echo results is equal to I think you can do something like this, echo string x, and then echo, and then we just echo result. They are not the same. Okay, so there's one line. Okay, there's a new line. Okay, this is where we differ a little bit. So Bash, when it like processes the result of an echo, since echo produces like a new line, I'm not sure if it's like using the built-in echo, or because I think the echo is like, it's both a built-in and or wait, shell built-in. Like, if I say declare here, will that work? Okay, I'm gonna try like shell, like built, like yeah, bash built-ins. So if I say declare or test or hello equals hello. Actually, this is a parameter, so I have to do this. Okay. Or an argument. Okay, so now we echo hello. Oh yeah, I can actually, okay, there's no escape code, there's no escape for these. Let's see if I can just make that happen real quick here. Okay. If we have this, we advance, we consume this one and the next one. And then we just don't. Shouldn't we like return like escaped or something? I mean, okay, I guess we just, but the thing is, like, it adds this thing. Yeah, okay. So let's do not advance, but we check the next one. Wait, no. This is not gonna work because we're not, okay. Where did we produce the token? I guess we produce it, the whole thing here. The whole thing is a token. Yeah, okay, finish. Right. So that's the issue here. Like, we're kind of using the source text. Like, this is the lexer. And we're basically reading character by character and producing tokens, right? The issue is here, if we have this escape thing, we're just treating it as part of the text. I guess the process of the parse, like the process of like escaping should happen later. We just take this as the literal thing, and we have to have some kind of processing thing later, which turns it into the real string maybe. Because here we're just using the source of the source file. What is your age? I mean, I started coding when I was very young, like 9 or 10 years old or something like that. I don't remember now, but you know, when yeah. Every time I bring it up, it's just, I just feel that time flies. Where are we? Parse string literal. Right. So here, I mean, maybe it should be part of the execution actually. Because again, this string here is not supposed to be like, well, I guess we could allocate it because the parser has an arena. We could technically escape here or decode it. Okay. Now, what do we do? So basically, we're just looking for any... Yeah, I guess we just say... There, now, in Zig, when replacing things, you can use replace, standard memory replace. And we can do... Well, it's kind of first you want to use like replacement size, so you know how large it's gonna be. You can also just replace owned, perform a replacement on an allocated buffer of predetermined size, column as free return memory. I don't understand. Why does it need to be like what? Why does it care about the input being? Oh, this is the output. So we do need to know how large it is. Okay, so this one actually creates it. Oh, I see. So we don't need to know. Okay. So we get the output. Okay. So replace own will do that. So great. So we'll take your U8 allocator is self arena allocator. Input is gonna be the string. And the needle is gonna be / $, and the replacement is gonna be just $. And then we return that. There we go. Okay, so now potentially we can escape $, so we don't have to deal with all that. We can also, like, if there's something like this, it should probably just produce the thing that we want, but I'm just gonna do it like this for now. Now, does this work is the question. Skip type check. Declare not found. Okay, so we are not in like a full kind of bash. Those built-ins doesn't work here. That's good to know. Which is good to know because then there's a difference between this echo and this echo. Because this is like a program and this is like a shell built-in, and they could behave differently. Which may be the case because this produces a new line at the end and sometimes this does not. I don't know. maybe it depends. You're 19 and I feel far behind. I mean, you're not. I can tell you that. You have plenty of time to practice. And also, thank you, but yeah, I mean, yeah, I consider myself very lucky to have found this passion very early in life. So I am gonna say that. But I also will say that I couldn't gotten a lot farther as well if I focused more on it as well. But yeah, that is how life is. It's it turns out how it turns out. I don't regret anything. Okay. So, okay, well, let's remove this. So back to this. So basically, if we now run check here, as I said before here, or as we saw before, we have an extra new line in the runic version, in my version, because of echo always outputs a new line. So when we do this, we say that echo result equals this. This includes the new line, but I'm pretty sure that this does not include the new line here. And that's the difference. Like if I put printf here, which does not output a new line, we should see the exact same result. Yeah, still 22 lines there, 23 there. However, if I now use printf over here, it's gonna be the same, because printf does not automatically append a new line at the end. So there's a slight difference here between like how bash kind of, when you're binding to this and you're getting like echo in there, it won't actually put the new line into the variable, which is kind of weird. I don't know. Maybe, you know, there's probably a very good reason for that. But I don't know. I feel like it's more correct to take the actual output that you got and put it where you want it to be. I don't know. But yeah, so this is, if you want to, basically whenever you have like a binding, use printf then, if you don't want the new line in there. If you just want to echo something to the screen, to like log something, use echo, because that appends a new line. Now also like printf is kind of, you know, printf you can add, like you can have variables here that you can format in different ways. Now I'm thinking that, well, I don't really need to have it in my language like formatting. I just have string interpolation, and then if you want to format something, you can use something like printf. So I'm not gonna, I'm just gonna do very basic here. But yeah, the string interpolation is it does try to coerce things. We can look at that now actually. So numbers, right? So numbers is right now, numbers are a little bit, you know, up in the air on how it's gonna work, because I'm still debating whether or not I'm gonna have several types of numbers, or just one type, which is like float 64 or something like that, or depending on operating system. But if the numbers are so basically you can have like, you know, you can have like my integer is an int of 3 or something like that, and then here is like, well, let's just use this so we don't have to type the thing. What is this? Okay, anyway. Okay, so this is my integer. Let's see. Yeah, and then we have like my float, you know, 2.5. And here's like my float, 2.5. And then we can echo my integer equals my integer, my float equals my float. Okay, so far so good. Let's echo my integer equals my integer, and my float equals my float. Okay, so far so good. I think these should all be the same. Yes. Now here's a difference. So now I echo my integer plus my float equals. Okay, I'm gonna wait with this a little bit. We'll do this first. My integer plus my float equals. Now I think I've recently like learned this. Well, basically, actually I'm not sure how this works here, but I think if you have this, now this is like any kind of expression in here, I think. And then you have to have like double parentheses. Now we're in kind of like number expression land, I think. And then you do like my integer plus my float. Okay, I'm just gonna double check this. So let's say you have 5 plus 2.5. Okay, let's do like echo. No. Do you have to have like something like this, or wait, error token 0.5? What? So you can't have point? Like, how, what, how, what? Okay, 1 second. See why I'm trying to make my own language? Arithmetic. Okay. Wait, so does bash not have floats? You can use, it doesn't have floats. You can only use integers in arithmetic expression, but you can use external utilities like BC for high precision or awk. Okay, so okay, here's like the first feature, I guess, that my language has that this does not have. You can't have a float. Unless you're using an external thing, but I mean you can do that in my language as well. You can use external utilities as well. Now what the hell is BC? Do we have... The language supports arbitrary position numbers in interactive execution of statements. There are some similarities in the syntax to the C programming language. A standard math library is available by command line option. BC basic calculator. Okay. Okay, thank you. Okay, there we go. Hey, okay. So does this count as a bash feature? I don't think so. But anyway, okay, so this, okay, so let's do the bash version then. Now, a question here, is this possible here to do like my float equals this? Oh, hang on. I need to. There we go. Okay. Can you do this though? Yes. Okay. Okay. So this should. This is like setting it to, I guess, the string of 2.5, and then you can do all that. Now, instead of doing this, then we will do BC. Well, I guess we have to echo my integer plus my floats into BC. Okay, there you go. I mean, it is a little bit unfortunate that bash doesn't have float, because the first example here looks like weird. It looks very weird. Maybe we should have a different example first, like const a my integer a equals, you don't have to type int there, by the way, but it's gonna get inferred. I'm just gonna say this. So let's say that this is 4, and then another integer b is 3, and then we echo my integer a plus my integer b equals, and whatever that's gonna be. You may see it already, but here we say my integer a is 4, my integer b is 3, and then echo my integer a plus my integer b is equal to, and here we can use the double parenthesis thing, I think. So if my integer a plus my integer b, yeah. So that's the first, like, okay, let's say they're like integers. And here we have floats. Oops. Okay, so the bash is done, I think. Now, if we do this one, it's just gonna be, you know, my integer a plus my integer b. My integer plus my float. They are not the same, okay. Wait, did I oh. A, there we go. There we go. They are the same. Okay. Cool. So this is like, this is turned into an integer in Zig, and this is turned into a float. And then we're just adding them together using Zig arithmetic. Also here. Now, you know, for things like overflow, I'm not sure. Well, this is like I don't remember exactly which backing integer this is gonna be, but I think it's like an I64, but we can choose whatever we want. in the implementation of the language. But yeah, cool. So that's that. Also, another thing is like we don't have to have a special syntax for each, you know, different kind of expression. So I think that's also a plus in my book. Okay. What else do we want to do? So we have basic commands here, if blocks, inline if, for loops. I mean, we have inline for loops as well, but whatever. With dynamic range, you just replace the thing with an n. Oh yeah, we also have like for loops of an array. So we have arrays as well. I guess we could have that, arrays. Although arrays are not fully, they are not fully like realized yet, but they do exist. You can make an array. So basically my array is actually let's do like 1, 2, 3. Okay, that's an array, and then we can for loop on the array, and we get the item, and then, well, let's use inline here, echo item. How is this done over here? I don't know actually. I have to look this up. Bash arrays. Also, every time I'm looking up a different thing in Bash, I get like a different top search result. It's kind of funny to me. Okay, so it's just a parentheses with a bunch of stuff in it. Okay, that's good. That's easy enough. Okay, so does that work? Can we now loop through the array? So we can do for item in, and then you have to do this special syntax here. There might be multiple ways to do it, I'm not sure, but you do this syntax, and then you have to have do like this. You could make it inline, I guess, as well, but whatever. And then done. Okay, it's gonna get interesting here, actually. Yeah. So let's see if this works. Oh, they're not the same. Oh. Wait, what? Oh, there's a comma here. Wait, what the hell? So the stars are bash. So bash. Okay, so if you have a string and then a comma, it puts the comma into the string. I guess this whole thing is like it's like a space separated list of strings. So the comma gets like, okay. So we don't have a comma. Let's remove that. There we go. You learn something new every day here. Okay, so now we have the two things here. Now let's have another, well, let's do it in bash first. So we have let's reuse the array. And then apparently we can loop over the indices. And then you do like for I in bang my array. So that's the index. So here we could do like I and then my array I think. Okay, that's how you do it there. Now in my language or in Runic, or you know, it's Zegu syntax really that I've stolen here. We still have my array, but now we just add another source, which is a range in this case. And now we get item and I, and we can do this. Let's put it in a block here. Okay, now that should be the same. No, it's not. Okay. Oh. What's happening here? Bash automatic string concatenation, yeah. Okay, well, in the example they had it like this. I thought that we might get away with not doing that. I don't know. Or maybe there's something else going on. No. Okay. Interesting. Okay, so it's like literally inserting my array. Okay, so you can't have that. You have to have, like, if you're going to access an array like this, you have to have this, I guess. If you have this, it's going to treat this as one thing, and then this is a literal open bracket, and then whatever indice, and then literal end bracket. But if you have this, it's kind of more like an expression inside. Okay. Yeah. So now these are the same. Cool. Okay. I guess also a difference is that I think my arrays are going to be very strict when it comes to what they can contain. They are only supposed to contain... I don't know really if I want that or not. Like the problem is the types. The type system is going to be very weird when it comes to arrays if we allow, you know, a 2 in here. I mean, I'm pretty sure this should work for both of them, but yeah, this works. But this is just going to be so weird with types here. I mean, technically we could make it into a tuple, where you have like a string, a number, and a string, right? But it's just gonna complicate things a lot. So I think I'm just gonna treat this as having, you know, an array of strings. And it's really not that big of a deal, to be honest. I don't think it's like a big of a deal. I don't think... Yeah. Mostly if you're dealing with arrays, you're probably dealing with the same thing anyway, so... Yeah, dollar curly... Yeah, dollar braces, dollar parentheses, dollar... Yeah, there's a lot of different ways to do it, and that's why I'm making my own language. It's like, I don't want to learn it. I don't want to have this in my head, and it's like every time... Like, I just block out everything that's bash here. I just block out of my mind. I don't want to learn that. Like, I don't want to keep this in my head. This is too much of stuff to keep in my head. I would rather build my own language to not learn this stuff. Because the problem is that every time, like, yeah, you could just look things up. But every time you look it up, there's like... Well, for one, the sources are like all over the place, and you can do things in many different ways. And there's like it's just so quirky. That's the problem I have with it. It's just like I feel like, hey, I have this programmer brain. I want to do something that I can do in a normal like programming language, but in Bash it becomes this whole thing. It's like, I don't know. I don't wanna downplay Bash, but for me personally, it just has been so much time invested in going in and looking stuff up, and you know, everything is treated differently, and I don't know. It's fun to build a language as well. Okay. So we have this arrays, floats, integers, bindings, functions, for loops, if statements, command calls. What else can we do? Can we use functions for pipes? I'm actually don't know. No, we can't, because there's no way to get the standard in. So yeah, that's what we're missing from that. Like, you can't pipe standard in from hello. There's no way to get the standard in kind of thing there from hello, or from the function inside the function. There's no way to like grab onto standard in and pipe it to somewhere. I've been thinking of doing something like this, like you have standard in and you pipe it to, I don't know, something, whatever, something like this, maybe, I'm not sure. Or, you know, there's a convention, of course. You have like one going in, or 0 I guess would be standard in, going into to cat. I don't know how it's gonna look, but yeah, I need to build the feature first, and then the syntax will be decided on later. But I know that I want to have it though. So yeah. All right. Now it's gonna be interesting as well, because you kind of have to think about, okay, where do I get blocked? It's like you can send, let's say you send standard in to something here first, you know, and then once that is like done, that means the standard in should be closed by this point. But then you could also have, I don't know, maybe some kind of way to switch the target or something. I don't know. I don't know what I'm talking about. Anyway, yeah. Now, okay, so I do want to check something here. I do want to check like functions that functions with pipelines inside. So let's say, or piping function, like piping the function into something else. So hello, I'm Runic, and then pipe that into cat. Right? And this should be the same. This should be the same thing there. Oops. Okay, I see. So bash had this, but the Runic one didn't. Okay, so that indicates that this does not work. Like piping out from a function does not work. Okay, let's explore that. So function as pipeline. So we'll have function. Let's keep the same idea here. Okay, now we pipe it into cat, and that should not work now. No. All right. What if we bind it? That should work, and then we inspect s. It's void. Okay. It's also, the thing is, when you use pipe, right, we want to make it like we want it to be streaming as well. It should have a streaming behavior. So basically anything that's, this is going to be treated as an executable. So anything that's like this, like, yeah, this is part of the pipeline. So anything that's streamed out of this should be. So I'm not sure why it's not working. Like this kind of makes sense because this like the function always returns a void because, well, if you had echo here instead, then this would be an execution because we return like, oops, because we return a, like if you execute something with, that is a command, we actually return it as a process ID, and whenever a process ID is encountered, it's turned into an execution result. But a function doesn't have a process ID. But I mean, it could still be turned into an execution result. We just have to have like a function. It just has to be. Yeah, we just have to treat it the same basically. But okay, but then also like, why doesn't it not work? Why doesn't it not work? Why doesn't it work with the pipelines? Because it should. Also, what does this produce? Oh, now we're stuck. Interesting. Okay, I found a bug. But okay, so that doesn't do anything. So yeah, so I have to figure that out. I'm just gonna be away 1 second here. I'll be right back. All right. Okay, let's see if we can figure this out. So, I think it's kind of the same when you have a block expression. Like, let's say we do like B is the block, the whatever, you know, result is gonna be here. I'm a block. Right? So if we run this, we shouldn't see any output. If we just inspect B now, we see it's a void, because all blocks, so basically blocks and functions are kind of the same like that. They turn into voids. However, they should be turned into execution results. So I think we'll start with a block, because that's more like a more like basic thing, like a basic yeah. So yeah, this runs the block in a thing, which should I mean, it should always be put in its own thing. Like, this shouldn't be a special kind of block or anything. It should just be what it is. We're not gonna have a special function for that. I'm just gonna run the block. And yeah, we're basically just doing this. And we can remove this. All right, and now you can see here as well, like we push this frame, we go through all the, but there's like, do something with these values. Now these values are whatever statements we have inside the block. It could be some multiple statements in the block. All those values that gets produced are basically thrown away. And then we have like the main result of the thing is like void right now, but we need it to be an execution result. So how do we do that? Well, we already have a way to do it, and that's in the binding right now. So what we do here is we set up a bunch of these pipes here to capture the standard out and standard error of the whole thing. So we're basically capturing the output of the thing inside. Now I think what I want to do is I want to encapsulate this in a more generic thing, so that we can use it both here and also sorry, I just hit the mic there, and also in the other places. So if we take this, I'm gonna name this like push, what would this be? Capture capture output frames. So this is gonna get us this. Okay, this is stored in here, so it will be available later on. Right, this is all we need to do here. And then we also have the pop capture output frames. which we could use to kind of restore the values, I guess, maybe as well. We could get this to get an execution result, actually. No, not that one. Is it value? So now, instead of doing this, we can just say push capture output frames. And, well, the processing, this actually does the capturing here in here. So maybe we do want a separate thing for that. I'm not sure. And these are like in the context, so we really don't need to put them in here. We can just actually just grab them out. I was just thinking that maybe we want to have a special thing, like it's actually just this. I guess we don't need to pop it yet. We could say this is like the actual capture output. It's gonna be this. And then standard out is scopes get standard out pipe. Actually, it should happen parallel, right? Or no, maybe not. This is a synchronous action, actually. All right. So then we store it in execution result. This is yeah. Store them like this. We can encapsulate this as well. Capture pipe. Let's just enable this as a optional, so we get an optional output as well. I guess we could just return an empty string as well. If so, this would be I don't really need self there. Okay. So now you are standard out results, standard error results. Oh, the exit code. Ooh. Right. Okay, well, the exit code is going to be if we have a standard out, then it's going to be the source get results. So it's kind of like it kind of has to have a result, I think, or maybe it doesn't have to have a source. I mean, so let's do a double if hype source. And well, it's nullable anyway, so oops. Okay. Now we process it. Now we can do the capture in here, so that's fine. So basically here we can do the capture. If it's a process, we will do the execution results. It's gonna be capture output. Now we do need scopes though. And we simply set you to this execution results. Okay. Pop frame. Okay. So instead of doing this, we do try self pop capture output frames. All right. So now we have, you know, these things we can now do and more easily other places as well. So let's see where we are. Oh, you need scopes. Let's move these around. All right. Okay. Now, so what is happening here? So, well, this shouldn't do anything. Whoops. Yeah, there's no difference here. But this is a block, right? Yeah, it's a block. So if we go to the block, now every time we do a block, you want to do the whole capture thing. The whole problem here though is the streaming part. Like, there's no issue in just evaluating all the blocks and all that synchronously, but the streaming part is where this gets a little bit hairy. It's like we want to be able to make the block expression return kind of like a pipe almost, or or like a closable reader or something like that. And then it's like, depending on the context. No, but okay. Let's see here. Like, what if you have the block in a pipeline? So it's like echo hello into a block that like takes standard in, or you know, however you wanna say it, into, I don't know, cat, and then does something else with this blah 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 blah, and then you pipe that output to something else, you know. Technically you could see that, okay, well, this is gonna get streamed into here, which is gonna be represented by this input here. This is gonna get streamed into cat and all that, and everything that's outputted from here is gonna get streamed out here. And moreover, you can have several statements in here. You can have like echo next one, so you have like multiple statements. So whenever this is done, this depends on the standard in here, but whenever this closes, this statement is done, it's on to the next one. However, we don't evaluate the whole block. Since we're part of a pipeline, we actually have to kind of create like an output for this whole block, and the statements are run in like a in kind of like an asynchronous fashion, like even during the execution of this, we should continue to stream it through, right? Because right now the pipelines are streaming. They are currently streaming. Like each one is streamed onto the next one and so on. But what we don't have is this kind of execution context that is also, you know, run in this execution thing. What the only thing we have is we set up a bunch of readers and writers, basically, that can be closed as well, and then the pipes in between to glue them together. And then we have a loop that basically forwards whatever output comes from here, it forwards into this next one. Whatever output comes from here, we forward it to the next one. However, we have no like execution happening in here at the same time. And that is the issue here. So this block is gonna block. And it's gonna run this first statement, stream that through until this statement is done. And then the next one is gonna stream that through as well. And that's gonna get buffered as it is right now. That's gonna get buffered in the next stage. Or no, it's not gonna get buffered. It's actually, well, it's gonna get put into whatever accepts it over here. Yeah. But not until this whole thing is done. No, actually, it is gonna get buffered. It is gonna get buffered because we haven't connected to. Yeah. So we are setting up the pipes first, but then they're not connected to each other, basically. This expression gets evaluated, which will connect its destination to this pipe source. And then we have the next one, which is a block. But this blocks the whole execution. So it's going to connect its source to this and destination to this. But nothing else will be here. So basically now this is now buffering all of this all of the output that comes from here. So what we need for this to be streaming is somehow, I mean, the thing is also, like, we don't know what happens here. Like, we're streaming this block. This block will become like an execution result. Well, that doesn't really matter. It doesn't really matter what's in between these pipes. The only thing that matters is if they accept a standard in and if they output a standard out. That's the only thing that matters. So this will get evaluated and then continue on to the next one. But what if, like, how could we execute it in parallel? Yeah, my mind is racing different, like, or trying to find different solutions. That doesn't involve spawning threads or anything like that. like forget about even this. Forget about multiple statements. Let's just say that we have one statement. So this block is going to set up this pipeline and then try to wait for it. That's the thing. Like the block doesn't know if it's supposed to stream out the results or if it's supposed to wait. I guess it kind of will know. Like we don't even have this anyway right now. We don't have a way to pass standard in to something. So if we had, we would kind of know if this block is like, I guess it kind of colors the block a little bit. Asynchronous. It's like an asynchronous thing. We could also try to have it always be kind of lazily evaluated, or, you know, asynchronous executed everything. And until we have something that kind of requires something else to be evaluated, then it pushes through. And it could potentially do it in like a streaming manner. Yeah, that's kind of what I was thinking of, like this producing a stream instead of producing like an execution result. And then when you want to consume the stream, it's going to get consumed. Like if you want to echo, let's say, well, if you just have an echo statement like this, it's actually gonna, you know, since it's a statement like this, it has to be, it's a side effect that has to, it has to like be executed. So you're not gonna get down here without executing this. But it's different when you're in a pipeline, because then it has to be asynchronously executed. So I think maybe we do need to kind of color this block to be in an asynchronous context. Maybe. Because you have this here. This is gonna stream into here. That's gonna stream into there, and then basically whenever this pipeline ends, it's gonna be connected to the outer context, which is over here. I guess we do kind of have a streaming thing then. We do have like the pipes themselves does have a streaming configuration. So if it's streaming and this like connects to a streaming thing, then maybe the block will kind of halt its execution on this line, or well, on this statement in the thing. Have it somehow be part of the main pipeline, and this continues to stream through. And then whenever this closes, or actually when this closes, it doesn't necessarily mean that this block will close. So this one close, which closes standard in there for cat, and then the whole pipeline gets run through as normal. So basically, first what we have, well, and then let's also say we have another echo hello at the end there. So first, what we have is this pipeline, echo hello into cat, into whatever is. So let's call this like inside block and then after block here. So it's kind of like this gets sort of expanded into this sort of pipeline. But then also when this closes, this closes as well, this closes as well. But it shouldn't close out here because the block actually has more things here. So it has more executions here. And then this gets kind of replaced with, well, since this closed, we now remove all that and then have the next statement be connected to the outside context. So it's kind of like when you encounter a block, we have to sort of expand the whole pipeline into multiple pipelines almost. And first run this pipeline, and then we run this pipeline when this is done. So we wait for this to be done, and then we kind of disconnect the source here, and then connect the next source. And you know, since this is a block, it should work for functions as well. Since functions are basically just blocks, except they have a little bit more context, like the parameters. They are basically just blocks. So it's like when you encounter, let's say we encounter a pipeline, right? And then the pipeline evaluates things inside. And then it evaluates a block. Because the block is kind of special at this point. So because it could have several statements inside. And the block could be either the result of just a literal block like this. It could be a part of a function call. Whatever. It's something that can run multiple statements. And potentially at that point like output multiple things. Then I guess we start to run the statements inside until we reach a pipeline or something that like outputs. Whenever something outputs, we connect it to this output and start to output into there. If we encounter something that connects like to standard in, we have to connect that and then do the same thing out there. And then whenever we run out of statements, I guess this is disconnected as well. So then this is closed and then the whole thing is done. Well, or this part is done, I guess. Maybe something like that. But how would this work? Could it be like a context thing then? Maybe we could have the, in the context, we would have like how to do the next, how to stream it through. Because it has to work like recursively and all that, so whenever we encounter multiple statements like this, this whole thing gets expanded, but how? Like, let's say we are in the run state here. It's like, yeah, well, I want to connect the standard in, and then this is going to connect the standard out. Okay, we encounter a pipeline. Okay, well, maybe the whole pipeline could have a forward function. Because we define the pipes themselves, but we never define like the whole pipeline as a runtime value. Because then you could just say, well, we run this pipe, we go through each stage, forward those, or each pipe in the pipeline to forward them. Now what does it mean to forward this one? Is that just a special kind of reader-writer stream then? That like has some execution inside as well? That could be the thing as well. Like we could implement this as a special reader-writer stream. Yo SQF, welcome back. Installing Gentoo and not good, okay. I didn't install it fully. What went wrong? Very impatient, okay. I think you have to be a little bit patient when you install a new thing like that. Just a tiny bit. Two hours to sync? Sync what? Alright, be a bit. I'm just gonna grab some coffee here. All right. Because to get to source space takes a long time. Sync emerge like sudo apt updated repos took 2 hours. Okay. Well, I haven't installed it in a long time, so I don't remember exactly. But that sounds insane. I mean, I used some kind of installer. I don't know. What do you mean is source space? Did you have to compile the whole thing or what? I guess there might be like different ways. Another person told me it took them 17 hours. What the hell? I don't remember this at all. I had to compile all packages. Okay. I just, I mean, there might be different ways, but I mean, what I remember, there was just a bunch of checkboxes I had to click in and, well, click. I say click, but basically it was like a terminal-based thing, the installer, and then it just, I don't know, what kind of installation are you using? You had to compile everything. Why didn't you use one of those installation like things? What's it called here? Like live GUI, USB, live CD, DVD, installation CD. I used the live installation TTY. Okay. I don't remember having that much trouble, but 2 hours doesn't seem. It doesn't sound that bad, to be honest, but yeah, the bare bones. Okay. Back in my day. Installing Windows on a new computer took a long time. And it had like a timer. Like it took so long. They had a timer that showed how long it's supposed to take, and then, well, the timer never worked, but like 100%. Syncing is only a small part. Okay. All right. I mean, if you're impatient, why don't you try one of those easier installations? Or can't you do that for some reason? I use Arch. Okay. Compared to Gento, Arch was easy. I just remember having to tick a bunch of boxes. Like, do you want this? Like, you could configure a whole bunch of things. I didn't remember it was that hard. Like, I didn't get stuck anywhere. Sure, it might have taken time to do some things, but maybe I was using an easier installation. I don't know. Hey, what's your theme? This colors. Okay, well, this one is called Tokyo Night. And then the font is called. I always have to look this up. That's the font right there. If we could get this working, like if we could somehow expand this into multiple pipelines like this, we could kind of churn through each pipeline at a time. So we could churn through this pipeline until the source, well, I guess it's like up to this point, because we don't want to close this one. It's like, let's say each evaluation here can produce multiple pipelines, or they have, yeah, they can produce multiple pipelines. We could use like a kind of a generator pattern where each stage will generate a pipeline, and so for this one, for example, if we just generate this one stage pipeline and it is done, and this one would generate, you know, 2 pipelines. So it would first start with this one, and then it would start with the next one here. Although there's a slight difference as well, because this connects to the source and this doesn't. So there, but we don't have that yet really. But you could, okay, let's do a simpler example here. Let's do like blocks as pipelines. Okay, let's say we have a block, and this one echoes first, and then echoes second. Right. So this does that, right? But then we put it into cat, and now this is just doesn't work because we haven't implemented this. But the way this would work now is that this would result in 2 pipelines. So echo first goes into cat, and then echo second goes into cat. However, there's also a difference because cat shouldn't like close its source port. It shouldn't close the standard in port when the first one finishes. So it's not straightforward just running this and then running this. Because we want this to be the same process that gets multiple things from this block here. Okay. Yeah, so this needs to keep the port open. We could also have like multiple sources, maybe. No. Multiple sources, but they will be like in a sequence. Inside block standard out wires to that block a pipe output. Yeah. So the kind of like how it works now is like if you have this pipeline, this standard out is put into the input of this pipe, and the output of the pipe is connected to the input of the cat. So that's kind of how this works here. We have these like things in between that connect to a source and then connect to a destination. However, like right now, when the source is done, how would you know? Like, how would you know that when the pipeline is done? It's like when the source is done, the stream has ended. Then, like, there's no more data. So we close the standard out of this echo, which also then makes it be able to close itself. And then also we close the output as well. We close the standard in of cat because there's no more data coming in. However, now we have like two different pipelines that need to have cat open. So there's gonna be a slight difference there. So basically, first, this is gonna connect to cat. Let's actually talk about this pipe here. So we have this pipe, and first echo connects to pipe source, and pipe destination connects to cat. And then when this completes, the source closes. But since we have more sources to go through, we shouldn't close the destination. And then we connect, then we spin up this next one, and we connect to pipe source again. But the destination, we don't need to connect the destination again. I guess the first one is like pipe, so pipe destination connects to cat standard in. 2 is echo first connects to pipe source. 3 echo first is completes. Complete since we have more sources. Well, it completes. Okay. 4. Do we have more sources? Yes. Or no. Pipeline or no. We're gonna disconnect, or we're gonna close pipe destination, which is the cat standard in. Yes, we're gonna spin up pipeline source and connect to pipe source. Spin up next pipeline and connect to pipe source. 5 is, well, this will kind of connect to pipe source. Yeah, and then 5 is like, I mean, okay, I'm kind of mixing generic with like a generic situation and this specific situation here, but basically when we have no more sources, we will close the destination, and then do the same for like the rest of the pipes or the rest of the things. So basically, pipe destination connects to next standard in, or connects to standard in of the context. And then, yeah, then what happens is that we will start to generate the pipelines from the expression. So the expression is kind of like, this kind of becomes like a lazy evaluate. Like we could, instead of evaluating the whole block, we could make it into like a generator where we say, well, now we want the next thing. Okay, so the next thing is this. Okay, that generated, did that generate some kind of, did that connect to the pipeline somehow? Okay, well, okay, so then we run that through. Okay, so then we're done with that. So now give us the next thing. Okay, it's gonna be the next thing over here. So that connects to the context and everything, and that will also produce a pipeline. So then we connect that and we run through that. And when we're done with that, we ask for the next thing. Okay, we don't have any next thing, so we're done. Okay, now we can close this. So we're kind of like a generator or an iterator, depending on what you want to use. So, yeah, so the block will become like not a finished kind of product, but it, well, in this kind of sense, in this context, it will actually be some kind of generator. I think the block evaluation will always become a generator, and then it depends on the context. If you want to consume everything at one point, like let's say you want to do like this, like const s equals a block that echoes hello. Let's say you have a binding. Hello again. So let's say you have this binding. Now, in the context of a binding, we actually capture everything happening in here. So we would know that we would need to consume the whole block and put the results in here. Okay. Yeah, so now we know that we should consume this whole thing, but when we evaluate the block, we don't know like if the parent or the context wants to consume the block or what. So we just produce some kind of iterator that will iterate through the statements. Okay, but in the context of a pipeline, we actually see that, okay, well, this becomes like an iterator. Okay, well, now we need to kind of take care of this iterator here. So at least then we would know, we would be able to say, depending on the context, how we would use this. And we could potentially produce multiple like sources here. So that's how we could do it, maybe. So then essentially each block becomes a generator, like automatically. And it generates a bunch of you know, pipelines, or I mean, I guess statements. We could do each statement, and then we get the value out for each statement. And then we just have to, I mean, but we have to make it work with pipelines then. But I think this is what we need in order to be able to actually do anything in the pipeline evaluator. Now it's going to get interesting. Like, let's say you get a pipeline, you know, when you run the statement, maybe we actually don't even run the statement. Maybe we do, Oh, there's gonna be issues with the context though, because this is gonna get run in a separate context. That's the thing as well. Do we need to like detach the scope somehow? I think this has to be run in like a closure. This turns into like a function. Okay, so this is actually a function now with its own scope. Of course, it has that. It already has its own scope. However, it's gonna get detached, and whenever we run it, that's actually like calling like a function. But that's not the same thing as well, because we need the iterator. The iterator needs to be able to be called. No, but it's like a generator function then. Yeah. The iterator has the closure as its context. So when we run the statement, we run it with a closure. Yeah. Yeah. And then the forwarding context is, you know, it doesn't affect the closure. So yeah, okay. I think we have our answer to how this could be possible. The only thing then is like gluing together it with the, like, whenever we get something out here, what do we do in the pipeline? But I think this is like the prerequisite of actually being able to do this in the first place. All right, cool. So let's think about this pipeline here. So, or the generator. So evaluate block expression. Now, the functions also kind of, they already like inherit this kind of thing. So really, whatever scope we're in, I'm not sure if we detach it now. Because if you're in a function, it's already like detached. Well, actually, you know what? No, because the block will produce an iterator. The iterator needs to have like a copy of the closure. I mean, it's the same thing if you call a function multiple times. You don't modify. Wait. Closure 2. Let's have a function. We have a variable I equals 0. Okay, and then we're saying echo I equals I, and then at the end we will add 1 to I. Actually, this doesn't exist yet, so you have to do this. So, okay. So what happens when we call hello? It would just put out I equals 0, right? Or not? It will crash. Okay. Why is it crashing? It's probably the parser. Yeah. Unexpected token. What? Oh, it's the binary thing. Okay. Isn't assignment a binary? It should be like a binary thing. Oh, I see. So this is like, yeah, this works here because we have a special keyword here for this, but here it doesn't work. So we need to have, let's go to parse binary. Do we have equals here or assign? Oh, that's terminator. There we go. So we have equal, equal, bang, equal. greater, equal, less equal, star percent. And so we don't have like a sign. We need a sign as well. A sign is a binary operation. A whole bunch of errors here. Where were we? So okay, so now we have a assign binary operation. So let's do execute binary. Actually, first off, I want to check now. Let's just print the AST. No, there's some issues here. Shouldn't happen. Parser 779. Oh, I see. This isn't okay. Right. So where's like a sign here? We don't actually have a sign. Equal, that's the condition. So let's add a sign. Now what is a sign? A sign. Oh shit. Alright, see you later, Penguin. What is a sign? It's probably kind of low. It's probably lower than add. Yeah. It's probably like the lowest. It also requires the previous to be something you can assign, of course. All right. Okay, so assign. I guess if you have like the previous one is some kind of weird expression, that's going to be a semantic analytic thing. So we're just going to assume that left-hand side can be assigned. Like we don't have refs right now, so it's gonna have to be an identifier. Or I guess it could be a member access as well. But that's weird. That's kind of like a ref. Like right now, this is gonna get evaluated to the value. If you have a sign, that's kind of like a different thing. We don't want to evaluate the left one. We want to kind of reference the left one. But we have like assign, evaluate assignment. But the assignment is, it doesn't deal with like yeah, it doesn't deal with expressions here. It deals with identifiers. Okay, so let's just say that we don't support member access or anything else that as an identifier. So let's just say if left is not equal to an identifier, we will report unsupported binary expression. Okay. Okay, so it's an identifier, so we can look it up. And if it doesn't exist, we'll return this. And then finding value. Well, I guess we can also check here if it's mutable. If binding is mutable, if it's not mutable, there should be like an error, right? Error, not mutable. I guess we have immutable binding. Okay, so now we're past all that. This should be like a semantic check, but right now it's an execution check. But whatever. Now we can do. We have the value, so let's. Well, we could just initialize the old value. Who cares about the old value, right? And then we will set you to something else. So you will be, well, it's just going to be like evaluate expression of binary right. There we go. And then that will also be the value that we return here. So we're going to do value clone. Because it's a new value. We set the value in the binding declaration, but then we also want to return like a value that can be used as an expression as well. Which has a bit of weird consequence right now, because if you're set like a stream or anything that can be coerced into something that can be outputted to the thing, it's gonna echo that out, basically. But okay, let's not think about that right now. Let's try and run this. We got unsupported binary expression. On line 9. Okay, well it does that, and then it says unsupported binary expression. So let's check what that is. Let's do it here. No, not parser. Valued binary, unsupported binary expression. Okay. See if we can get some more information here. Unsupported binary expression. So if we get this, we will log out expression cannot be assigned to. Oops. And then this one is like, I don't know, binary operation. So this operator, this not supported. So binary left, binary operator, and binary right. Expression call cannot be assigned to. Oh my god. Okay, yeah, okay. So this is a parser thing actually. Also, these need to have new lines. Yeah, this is a parser thing because the all the identifiers in a binary expression is turned into calls. So actually, where is that happening? Two expressions. So this is, yeah, this is turned into calls if we're not a member access, but now we also need to check if we are a or op is an assign. We don't do that. Okay, well, we don't really see what's happening here, so we still get this. Expression call cannot be assigned to again. Also, it should only happen to the left, actually. So there's a distinction between left and right here, actually. So we should have maybe like, what is it called in math when it's like left hand side or right hand side? Chirality or something like that. So Okay, if member is that, so if it's member, we don't care about chirality. If it's a sign, this chirality needs to be left. What's happening? Oh. There we go. Now this would be, I don't know, it doesn't matter. Left, maybe? Left, right. Okay, now it doesn't output anything. But do we get... The parser works, okay. So we call echo, yes, we have a binary which is an assign. Yeah, that's a binding, so this works. The binary assign left is identifying I, right is binary add I with 1. Why is this not turned into a call now? That should be a call. Except it doesn't really matter here, but it should be a call. Your language is called Runic. Yes. Is it public? It's available on GitHub. So yeah, you could call it public. You can use it, but I mean, it's not, you know, it's not in a functional state right now. These are not turned to calls. That's the issue. They should be turned to calls. Why are they not turned to calls? No, it should be and. Oh. Always that Boolean logic. There we go. Now we have the binding here, expression which we call echo with that, yes. Now we assign I, which is, this shouldn't be a call, what the hell? Why is that a call? Assign, character is left. Why is this turned into a call? I mean, it could be because of this, but I don't know. Yeah, it could be because of this part. But this, the left-hand side should be parsed as a binary. However, if it's only one component, it gets turned into... We don't know what the operator is. Although we could have a potential operator put in here, I guess. That would tell it the more of the context. Yeah. So... we should have an operator, which is the next component. This is the operator, and I is... what is I? It's this one. And since it's... we don't even need it to be in there. And let's supply operator to parse binary. Except the right hand side we shouldn't, because the right hand side, I guess we could pass chirality potentially. Yeah, we could pass chirality here. This is the left hand side and this is the right hand side. But this is like optional. So this would be binary operator and then chirality. Wait, where is that thing? No, it's a component. And so here we simply pass this through. There we go. And this one we don't need it because it's embedded in the thing. Okay. Cool. And here is like the root. So this would be null, and this would be, I don't know, left. Very good. Very good. Very good. Very good. Okay. Now it works. Yeah, thank you, Two-Step. Yeah, sorry, I should have realized I should have posted the link there. Sorry. Okay, we're back here again. Do we get more information now? Okay, operation call add. So call, what the? Oh, call add literal is not supported. I see, I see. I see. Well, if we got a call, we should evaluate it, right? like if we have a call on the left hand side, that should always be evaluated, right? Unless it's a pipe, I guess. But the pipes are not put in here anyway. That's a special kind. Okay, well, yeah, let's say, well, we evaluate the thing. Wait, it should get evaluated. It's already evaluated. I don't understand why we get this error here. Well, okay. So something goes wrong in here. The left-hand side should be an integer. I mean, it's like coerced, or not coerced, but it's inferred to be either a float or an integer. But I guess if we get out here, we could log how did the parser turn out? How are you handling precedence similar to Pratt? I think it's similar. Not sure. I mean, I can show you a little bit here. Basically, a lot of things boil down into this binary parser. Oops. So basically, what we are doing. I mean, I'm going into the code. It's probably better to just try to explain it. But basically, what we're doing is, if you have an expression like this, like a plus b plus 1 plus 3 times, or, well, let's simplify it a little bit, times 2 plus 4. So if you have an expression like this, every component here is going to get put into a list like this. So we'll have a, we'll have plus b times 2 plus 4. So first, oops. So first we are going to say that these are the components of the binary expression. So basically, the operators are mixed in with the kind of what you would call them, the terms here or whatever, the operatees here. So they are kind of intermixed here in this big old list. Okay, now this might not be the perfect, data structure or whatever for this, but that's how it works. And then we're basically going into a loop where we're looking for each operator in the, for each operator, let's say binary operator, which in this case is plus and times. We would look for find lowest precedence operator. So the first one, the lowest precedence, should be plus, because times is higher, has higher precedence. So plus is like the lowest precedence. Okay, and then we group. So this is 1, 2. We group components between the lowest precedence operator, the LPO, let's say. So this means that now we should end up with a couple of lists here, like A plus B. So we have a group now, basically like this. Like conceptually, this is how it's grouped. Actually, let's use. Well, they really are arrays, but I'm just gonna do this like this. So then we conceptually we group. No, the other way around. This is plus. Sorry. That's gonna be a group, and you are like a group with one thing, and you're gonna get a group there. So basically, in between the lowest precedence, which is plus in this case, we're grouping every list of components here. Okay, so now we have a new list with all the same kind of precedence in here. Now we apply a recursive algorithm that will look at the first, like first we look at the, so this is like parse binary expression. First look at, so is length equal to 1, then return, you know, return the component, like the component as is, because then it's just 1 like this. This is 1 here, so this just becomes the thing that's inside. 2 is length equal to 3, then we have a binary expression. So then we have something like this. We have this binary expression. So then return binary expression with, you know, left hand side times right hand side. Okay, otherwise we will take the first 3 components and store them as the new left hand side. So basically take 3, store in LHS. So that is the new left hand side. So basically we have like a left hand side define mutable left hand side, which is some kind of binary, you know, a binary expression. So we store these 3 in LHS. Well, that's what's going to happen here, because the length of the thing we're looking at has like 1, 2, 3, 4, 5 different elements. So we'll take these 3, store them in the new left hand side, and then we'll repeat the process. We consume these 3. Now we're left with, well, the new left hand side is going to look like this, where these are like 1 expression now. Okay, so this is 1 expression, and then we take the next 3. Well, we actually see that this is equal to 3, so we just return this as a binary expression itself, because we have 1 left hand side plus and then 1 right hand side, and then we're done. So that's it. Then we're done. And then we also call it recursively on the inner part. So this plus here, this inner side here is called recursive. This thing is called recursively on this side. Like, I'm not explaining this in a very good way, I just feel like, but this is basically how the algorithm works. We're recursively like grouping by lowest precedence. When the lowest precedence is done, we will look for the next operator. Well, actually, we don't really need to do that. We don't need to like loop through all the operators. We just look for the lowest precedence and do that. Because when you get in here and this algorithm is recursively applied here, we look for the lowest precedence, but there's only 1 operator, so we just need to return this. It's only 3 elements as well, so we just need to return this as a binary expression by itself. So yeah, so that's how it works, and that works for, you know, everything basically that works as a binary expression. And I actually put a lot of binary expressions here. So if we go to the AST, you can see that here's all the binary operators we have right now. We have like the math stuff, we have the conditional, like, or the comparisons, we have the booleans here, and then we have like pipe, which is the pipeline parser. We have apply, which is function argument application, and then we have member, which is like, you know, object dot member access. And then we have assign here as well, which I added right now. So it turns out like a lot of things is, you know, binary expressions, and it works really well if you want to have a lot of expression-based things. So yeah, I don't know if you could classify this as a Pratt parser, but you know, it, it was kind of based on my idea that you would group you would group kind of like these components by lowest precedence and then go through each one. So it's kind of like, you know, I don't know, a recursive thing, lowest precedence thing here. But it works. Probably not like the best thing, but I do enjoy, you know, making up my own things as well and trying to apply them. Sometimes it works, sometimes it doesn't. Yeah, the code is there, so the basic components there is there right now. Like I'm doing modifications to it right now, but the basic like idea is there, so you can look at it. Okay, but anyway, what is going on? So it still says that the call add literal responded. So I want to add more information here about why this didn't work, because now we actually have the values here. So add expression not supported for, and then we have these three things. So t, and arguments are going to be actually this could also be the operator supported for, and so this is like the operator or binary operator, and then this is the left value and the right value. Okay, and that could be inserted into all of these different things, but let's just see what it says here. Add expression not supported by void and integer. Okay, and also I forgot to add this. Void. Why would I be void? We call I, that should just be call expression. Yeah, if it's a function, we run the function. If it's not a function, we clone it. We clone the value, which basically, do we even need to clone it actually? Why do we need to clone it? Oh, because we deinitialize here. Okay, well, fine. So we clone the value out. So, but the value itself should be whatever is stored in the binding. So that's strange. We could also inspect I. It's an integer, which is 0. Interesting. So why does the call turn it into a void? I mean, I guess, well, the assignment hasn't been evaluated yet. Like, we're evaluating the left-hand side, right? Which says binary expression cannot be assigned to. Oh yeah, so we're evaluating the left-hand side, so that works. And then we're looking up. Wait, we're looking up the left-hand side. Oh, we're deinitializing it and then. Oh, okay. Well, let's copy the value first. Wait. Binding value. So this is like the previous value is binding value. Okay, let's copy it first and then we deinitialize the previous value. There we go. So we deinitialize it, and so when we evaluate this, whatever refers to I at that point won't see it. Okay. Okay, there we go. Okay, so now we can see there's a 1 there. It's kind of hard to see, but closest to... why does it say 1? Oh, it's because this turns into a string. Okay, here's the issue now. So basically, I had the idea that, you know, you can have the hello world like this. You know, this is hello world in Runic, which is kind of cool. I mean, hey, whatever is like, you have some string just as an expression. It's gonna get output into hello world. All right. And even, you know, if you don't have a new line, it won't output a new line. We don't really see it here, but yeah, if you do it like this, you see that there's no new line here. So it's perfect to me. And there you can see there's the new line. So, but if you have like const I equals 5, and then you say like I equals 2 plus 3, well, it's the same thing. I plus 5. Let's say if we just declare this, that won't like evaluate to a value because it's like a statement. But this is also, well, this is not a statement. Well, it is a statement, but it's like a statement expression. And so it turns into a value. Yeah, like you can use this as a value. Like if you say j equals this, and then we just echo j out. We have to skip type check though. We get nothing. Okay, immutable binding. Oh, right. So wait, immutable binding. Oh yeah. So I needs to be like mutable there. So here we can see 10. Okay, so I is, I mean, that makes sense. I is set to 5, and then we reassign I to be I plus 5. So the result of this is 10, right? So this should be 10. So yeah, that's what it is. Okay, and we can even, let's do this so we don't get so we get a new line there. So that's 10. But if we just say, you know, I equals I plus 5 again, then this will become an expression that turns into a value that is coercible to a string, and so then that also gets outputted out to the screen. So this statement here is like, do we want this to be like, do we want to treat this special as a special statement if it's by its own, you know? And even if you have it, like, let's say you have a block around it, this also, you know, gets outputted because the whatever's outputted from the block gets outputted to the thing outside. You could do this, perhaps. That will become an unsupported binary expression. I see. Okay. Well, maybe like this. Okay, there we go. So that if you do this, then you don't see the output of this. But it really feels like this should be such a, I don't know, this is such a common thing you would try to do, perhaps. So any kind of assignment should probably not get outputted if it's like the only statement, you know, in the thing. But it's like, it's kind of weird. Like, I like it when you can assign something and it will become the expression itself that you can store somewhere else. But then again, here it has to be specially treated. There might be other statements that also need special treatment. But okay, I just thought that was a little bit interesting. I'm not sure exactly how we're gonna solve it, or if we do solve it. Like, you can do this to make sure that it doesn't actually output anything, and you know, it's easily testable and all that. So I don't know. Maybe we just say that, hey, if you make an assignment, it's the only thing in the statement. We won't actually output it. Perhaps. I'm not sure. I don't actually know. But you could do this as well, which will execute the assignment and would also output the thing as well. But this won't. All right. Anyway, where were we? What happened? Where am I? Oh shit. Yeah, I have to go basically now. Or well, I could probably be here for maybe 10 minutes more or something, or like half an hour. Let's see. Yeah, no, actually, I probably have to go right now, actually. Yeah, so I just want to gather my thoughts of what we actually need to continue with, just so what we left off with here. So I think we solved the issue with the thing. We did this, we started to do this part. Okay, this works now. Okay, what I wanted to test here, you know, is that this is a function declaration, right? Now, each function declaration has a closure, which is kind of like capturing the outer scope. So basically, if I had, let's say I have an S here that is assigned to 5, and we can echo S as well. There you can see now it says S equals 5 because it's capturing the outer context here. And you can even have, let's say this is defined inside another scope. So let's make a block here. And now, well, we don't actually have access to this hello function, but okay, potentially, like if you could do that, like we do have, you can do it if you have a module. Like if we make this into a module, you could import the thing and call hello, but I'm not going to demonstrate that right now. I'm just going to demonstrate this, that you have an S here equals 5. We can access it from in the function, even if we call this from another context somewhere else, right? So let's also inspect S here. Fine, why not? And then I also want to increase S by 1 as well. So there you go. And let's discard these so we don't see what they do. Yeah, so there we go. Now, actually, we don't really need to, we can just use inspect here. Okay. Now, what happens if we call hello again? Will it actually modify its own closure to increase these things? Because that's what I think is going to happen. I think right now we're treating like these as kind of like references. They keep around. So if we call this again, okay, I shouldn't have done that, but okay, let's do that. If we call this again, we can see that first call I0 is 5, next call I is still 0 because it's like defined inside the function. So this doesn't exist yet. This doesn't exist in the closure. However, the S does. S does exist in the closure. So when S is called, or when hello is called, it will actually modify like S here, which it does make sense. You know, it's a closure, but I don't know. Normally S is like integers and primitives like this is treated as, you know, copy by value or whatever. This is kind of treated now as like a reference, but it kind of makes sense because S is, you know, it is S. So here it's a reference to the original S. I'm not sure if, does it work the same with in JavaScript? I'm just gonna check. So here we have S equals 5, function S plus equals to 1. We log S equals to S. Oh, let's just do that. And then we call hello. And then S equal to 6. Oh yeah, we have to do this to make it the same. One second. Okay. See? It does like S equals 5, S equals 6. So it does the same thing. So yeah, that's kind of the idea. This is captured in a closure. It's you know, and if you have another function called hello2, will this refer to the same thing? It will. Okay, that is interesting. I'm not sure if my language actually does that. No. Or, wait, I'm not even calling this one. There we go. It does. Okay, there you go. We actually got the JavaScript-like closures. Okay, well, okay, so that was just a note on the closures there. Because, yeah, I just wanted to check. Well, okay, anything that gets defined in here gets like, you know, that's not part of the closure, basically, you could say. But anything that's outside will be part of the closure. So yeah, I guess that works. What did we do? Yeah, that's what I wanted to test, and now it works, so great. Now what? Yeah, we were doing this thing. Yeah. Oh my god, yeah. Okay. So yeah. Well, okay. Well, I have to go now, but yeah, this is gonna be very interesting. This whole pipeline thing with blocks being able to be piped into, like in a streaming fashion, into a pipeline. Yeah. But yeah, that's gonna be it for this time. So thank you very much for joining and watching and chatting with me here. And hope you have a nice day. And I'll see you later.